guys, we're all the seekers lost in this forest. How are we supposed to find a way back home?
Don't worry, guys. I know something that will happen that will help us get out of here.
You really think there's a way?
Look! There's a man!
A man! Sir, can you help us? We're lost in this forest and we don't know how to get out of here.
Hey kids, there's a reason why this happened to all of you. You probably those kids who hate mathematics, am I right?
Who would even love math?
That is what I mean. In this forest, you will get to share your knowledge in mathematics with nature, and you will soon learn how to love math.
Hey guys, let's just listen. It'll be a big help. So sir, what should we do?
If you go straight from here, you will see trees with sign. And there will be papers above the roots of the trees which contain the question that you need to answer in order for you to get direction to get out from here. Good luck! The objectives of your journey are these. You must learn the definition of conditional, biconditional, related statement, and symbolic arguments. Comprehend their differences and know how they are used in the modern world.
Huh? But sir,
What did he say?
let's just do it, okay? Find the trees with signs and let's answer it together.
What? That's absurd.
Just do it, okay?
I can't believe that the questions are all conditional, biconditional, related statement, and symbolic argument. This is my most hated topics.
As the man said, we'll get to learn mathematics here.
Come on, let's find the question.
I got the first task. It says here, in mathematics, there are statements called mathematical statements which are declarative phrases that is either true or untrue, but not both. What are the three different mathematical statements? Give its definition. I got this, guys. I've heard this from Miss Lagrada on our class before. First is the conditional statement, which is a type of mathematical statement that asserts a relationship between two statements, often referred to as the antecedent or the consequent. It is typically expressed using if and then, structure with general form written as if antecedent, then consequent, where the P is the antecedent and Q is consequent.
So for the second one, biconditional is a type of mathematical statement that asserts that two conditions are both necessary and sufficient for each other. The biconditional statement is typically expressed using the if and only structure, with the general form of statement A, if and only if statement B.
I'll do the related statements. In related statements, we have three: the converse, the inverse, and the contrapositive. These three can all be in a conditional statement. So when you say converse statement, it is a related statement to a conditional statement that involves switching the positions of the antecedent and the consequent. While a conditional statement asserts that if the antecedent is true, then the consequent must always be true. The converse statement asserts the reverse relationship. Formally, if we have a conditional statement in the form of if P, then Q, the converse statement is formed by switching the positions of P and Q. Now it is expressed as if Q, then P. So that is the related statements. And for the inverse and statement of a conditional statement involves negating both the antecedent and the consequent of the original conditional statement. It is formed by adding the negation to both parts of the conditional statement. If the original conditional statement is if P, then Q. The inverse statement is if not P, then not Q. So, for the contrapositive statement of a conditional statement, it involves negating both the antecedent and the consequent of the original conditional statement and switching their positions. Now, it is formed by adding the negation not to both parts of the conditional statement and interchanging their positions. So, if the original conditional statement is if Q, then P, the contrapositive statement of this is if not Q, then not P.
So that's it? Are all the topics defined?
Yes, I guess. Oh, look! It says here it's correct!
Yes! Ah!
Here, next task! Let's go!
Let's go!
Give an example of conditional statement and provide an example of its converse, inverse, and contrapositive. If it's raining, then the ground is wet, where the antecedent is it is raining, and the consequent is the ground is wet. Its converse is written as if the ground is wet, then it is raining. Inverse, if it's not raining, then the ground is not wet. Contrapositive, if it is not raining, then the ground is not wet.
Hey, look! It says we're correct! Let's up to the next tree! I got it! It says, how are the trees used in the modern world?
I'll answer that. Conditional, biconditional, and related statements are widely used in mathematics, computer science, artificial intelligence, law, and everyday decision-making. These statements are fundamental tools for logical implications, decision-making, and effective communication in diverse tasks.
Whoa, that's right! It says correct! up to the next 3. Let's go! Here!
What is symbolic argument? Symbolic argument refers to a method of reasoning or proving mathematical statement using symbols, variables, and logical deduction. It involves manipulating these symbols according to well-defined rules and logic principles to establish the validity of mathematical argument. They allow mathematicians to reason abstractly and generate the results beyond specific instance.
It says here, give an example. I have 2 examples of this. Let's say our first premise is, if Aristotle was human, then Aristotle was mortal. Our second premise is, therefore, Aristotle was human. Therefore, our conclusion is, Aristotle was mortal. To solve this for its symbolic form, we're gonna let the H represent the statement, Aristotle was human. Then we're gonna make the M represent the statement, Aristotle was mortal. Then conclude that Aristotle was mortal. Now let's see. Yeah, we're correct! We're right!
Yes!
Yes!
Up to the next 3! Now, next, it says here that what is the importance of symbolic arguments and how it is used in the modern world. Well, symbolic argument plays a crucial role in the modern world by influencing public opinion, cultural narratives, and driving social and political movements. In the era of information overload, symbols have the power to cut through the noise and capture attention, making them effective tools for communication and persuasion. And understanding symbolic argument is crucial because it enhances communication, unleashes persuasive power, promotes critical thinking, and fosters cultural and historical understanding. Symbolic argument also encourages critical thinking and interpretation. As symbols often contain multiple layers, it means that we require thoughtful analysis.
Let's see. Wow, we're right!
Yes!
Look, the man!
Yes, yes!
How was your journey, little kids?
Hey sir, we cannot believe that we enjoyed our journey. We realized how important it is to love the mathematics, and we can't believe that we got to answer the questions, right?
Yes. Exactly, that is what your journey must be. You must love mathematics because it is important. A love for mathematics empowers individual to think critically, solve problem, and apply mathematical concept to real life situation. Congratulations for passing the challenges. I hope you will love mathematics more after your journey here. Go beyond those trees and get your way home.
Thank you,